Right, Quantum 101. This stuff is well hard to get your head around. So let me break it down to you with a fun example. Let's start by saying what it is. Quantum physics is the rule book that tells tiny subatomic particles how to behave. But since big things like us are made up of tiny particles, quantum physics is really the rule book for everything. But it's only when we start looking at things on tiny subatomic scales that we really start to notice just how strange these rules can be. Let's take a very tiny thing, the electron, and study one of its properties called spin. Imagine that I'm the electron, and I could spin either to my left or to my right. But I could also rotate over my head either forwards or backwards.
Before getting to quantum, let's first see what happens in classical physics, in a situation where I'm rotating in two different directions, flipping backwards and spinning left at the same time. And we want to know whether I'll be facing away from or towards the camera when we take a photo, which in physics we call making a measurement. If we make our measurement just after I take off, I should be facing away from the camera. In classical physics, we could predict this because we know my rotation in both directions. But in the quantum world of the electron, things aren't so simple because it turns out it's impossible to know both of these properties simultaneously.
In quantum physics, there's something called the uncertainty principle, which makes it impossible for me to know my rotation in both directions at the same time. But we can be certain of one. So let's say that we know that I'm flipping backwards. That means that we can't be certain whether I'm spinning left or right.
In fact, the state of definitely flipping backwards is a 50-50 mixture of left and right spin. This is called a superposition state, which you can think of as multiple possibilities happening at the same time. However, we never actually see superpositions in the real world, and this brings us to the strangest part of quantum physics, which is measurement. The act of measuring a quantum system changes what it's doing. Here, we're not certain which way I'm spinning, but we can make a measurement to find out. Since my superposition is in a 50-50 split of left and right spin, half the time we'll measure left, and half the time right. And because of that, there's no way of knowing in advance whether I'll be facing towards or away from the camera in the photo. Let's say that we've happened to measure spin left. Now that we know that I'm spinning left, the uncertainty principle means we've lost all knowledge of whether I'm flipping forwards or backwards. In fact, the state of definitely spinning left is a 50-50 superposition of flipping forwards and backwards. So measuring the quantum system hasn't just changed what we know about it, it's changed the state of the system itself.
And that's the essence of quantum physics. You can never know everything about a quantum system. You'll always be uncertain of something. And if you measure the system to try gain more knowledge, you change what it's doing.